Welcome to Further Solutions Academy once again. This is the best blog for you to watch your science videos, tutorial videos on physics, chemistry, mathematics, and even engineering concepts. And do well to like and subscribe to our page. And for today on chemistry, we will be discussing on the calculation of pH and POH of solutions. Now, you should know that pH is also known as the power or the potency of hydrogen. As this information gives us, is the pH is the power or potency of hydrogen. Now, the significance of this information is that it makes us to know how acidic or how alkaline a solution is. How acidic or how alkaline a solution is. And on the pH scale, we have a pH scale of about 1 to 14. And we know that when it's at 7, it means this is neutral. So the pH of 3 compared to a pH of 6, which is known to be more acidic. Okay, we have here to be acidic and we have here to be alkaline. So when we are comparing the pH of 3 and 6, which is known to be more acidic, we know that this is known to be more acidic, and because this is tending towards the neutral position. And there is also something, or one formula we should know, is that our pH, just for the one of hydrogen, plus POH, which discuss or covers the one for the hydroxide, is equals to 14. Is equals to 14, just like we have it on the scale. And likewise, our hydrogen concentration, this is hydroxide. Our hydrogen concentration with our hydroxide concentration is equals to 10 raised to power minus 14. This value is known as Kw, and Kw is the ion concentration of water. Like we know, our water comprises of, in other textbooks, you may not see hydrogen as this, you may see it as H3O+. Either ways, we are still talking about the acidic concept of that solution. So with this, let's just check on some problems or some questions that may refer to pH and POH. Thank you. Alright, so we have some questions on the board that as regarding pH and POH that I would like us to examine before the end of this tutorial video. So first, we have a question that says calculate the pH of 0.001 molar. Now, please take note, some students misunderstand this. This also means mole per dm cube. 0.001 mole per dm cube of HNO3 solution. So we are told to calculate the pH. I'm very sure some of us are familiar or conversant with this formula. This formula that says pH is equals to minus log 10 of hydrogen concentration. Now, you may see it this way, or you may see it as minus log 10 of H3O concentration. Now, it's either of the two. Like I said, this could be replaced for this, and either ways, it means the same thing. So now, we have this, and this will take us back to mathematics, our basic mathematics, of course, where we'll be using our laws of logarithm, laws of indices, and many of these laws. So now, we have our hydrogen ion concentration, because this is the acid, and this is the molar distance for the acid. So we could know that this HNO3 is giving us H plus NO3 minus, right? So we have just 1 mole. So if this is the mole for the reaction, it means that because this is a 1:1, so we have 0.001 molar of this and 0.001 molar of this. But we are concerned with this because we are looking for the pH, right? So looking for the pH, it means that we use our equation that we have here, we use it down here. So this pH is equals to minus log of 10 to 0.001. Now let's just do a bit of standard form here, and we realize that this is also minus log 10 to give us 10 raised to power minus 3. I believe I'm correct. And based on our laws of indices, where we have log A, x raised to power b, we can say that this is b log ax, right? b log a b log ax, yes, bringing our b over. So we will apply that law in this particular situation. So this becomes minus 3 log 10 base 10. Log 10 base 10, right? So this is like interpreting this particular law of logarithm to get to this point. And after getting to this point, let me bring another law in logarithm, which says that log a base a is equals to 1, right? Log a base a is equals to 1. So likewise, when we have this, we'll be having something like minus 3 times log, okay, there's a mistake here because initially we have a minus here, right? So if we are interpreting this to be this, it means that we are bringing this down a bit. Let me get the, all right. It means that if I'm bringing this down to this point, I'm having something like this, minus into minus 3 log 10 base 10, right? And I said another law of logarithm that we use here is log a base a is equals to 1. And here we realize that we have log 10 base 10, which means that we're having minus 3 times 1. So this gives us positive 3. That means our pH for this acid is 3. And if I should ask you, is this acidic? Is this highly acidic? Yes, it is, because 3 is quite, for a pH, is quite high for an acid. So let's go to the next question. The next question says that we have the hydrogen ion concentration H plus in a solution is this. Now, we don't need to go through all of this because we are not giving just the solution. We are giving that of the acid particularly, which is H plus, and we are giving the concentration to be this. And now, here is the gist. We are not told to look for pH, we are told to look for POH. So that means we need to put all the formulas that we know into getting this. Remember, before we even get our POH, we need to get our pH because we are given hydrogen ion concentration. And recall, I will be dividing this. So recall that our pH is equals to minus log of hydrogen ion concentration, right? Yes, hydrogen ion concentration. Hydrogen ion concentration. So we have been given the hydrogen ion concentration here, which says that our pH is equals to minus log of 5 times 10 raised to power minus 3 base 10. Don't forget the base 10 because it will be needed when we have something like this, right? Okay, so having known this, we would apply our laws of logarithm, which we know that when we have a multiplication sign in our logarithm, it's talking about addition, where we say log A plus log B is equals to log A times B. I believe that we can relate this with what we have here. Right? We can relate this to what we have here. So what this is saying is we can as well break this down to have something like this. Our pH is equals to minus log 10/5 plus log 10 raised to power 3. Do we get that? Do we get that? So we are just interpreting this under this particular law of logarithm. Under this particular law of logarithm to be this, right? So this furthermore gives us our pH to be equals to minus, don't forget this minus, log 10/5 plus. Recall that we, just like what we had here, we can do the same here, but I don't want to go through the same process because you can also see it here. So this automatically gives us something like this, minus 3, right? Because this becomes 1, right? So, all right, so I can close my brackets. Okay, so if I bring this, I have minus log 10/5 minus 3. I would advise that you don't do this the way you see it. Don't just get log 2. Mathematically, we cannot get log 2. So we need to break this down further. So what it means is we need to get what log 5 is, because this is a number, right? So in fact, it would be right to even do this so that I can do this as a number. And from our calculator, we'll see that log 5 is minus 0.6990 minus 0.6990 minus 3. Let me confirm that from a calculator. All right, so log 5, okay, 0.6990 minus 3, right? So if I want to do this, then I will be having something like this. To multiply this, the minus, that would be minus 0.6990 plus 3, right? So minus 0.6990 plus 3 will give me 2.3. So this is the pH for this equation, right? This is the pH for this equation. But remember, we're told to determine the POH, not the pH. So we are not done, because pH plus POH is equals to 14. And we have been given the pH. We've calculated the pH rather. So we know that this is 2.3 plus POH is equals to 14. So our POH is equals to 14 minus 2.3, which is what? That should be 11.14 minus 2.3 should give us 11.7 as our POH of this concentration. I hope we understand that, right? Let's go to the third one. All right, back again to the third one. Remember I said there were a lot of formulas that we need to know that would enable us to be able to solve. I believe that after watching this tutorial video, you should be able to answer any question as regard pH, POH, hydrogen ion concentration, hydroxyl ion concentration on any concept. So now, back to this question. We were told that we have a solution of this hydroxide. Remember, because this solution, this concentration is for the compound, excuse me, is for the compound. So remember that NaOH will give you Na plus plus OH minus. So that means this is 0.02. Because this is in 1:1, so that means this is 0.02 and this is 0.02 likewise. Now, the reason is there are some situations where this may change. Just let's watch out for the next question. I think I will give us a question on that, and we'll see how this may vary. So try to watch it to the end. That's what I mean. So now we have our hydroxyl ion concentration to be 0.02 molar. That means we've gotten this, right? Now, the beautiful thing about this question is you were told to find this, and this. Don't just rush into getting your pH. Don't just rush into getting hydroxyl, your POH. You need to start getting the answers from the beginning. So we've gotten this, and we know, or we are aware, remember I said earlier, that our hydrogen ion concentration multiplied by our hydroxide ion concentration is equals to 10 raised to power minus 14. So we don't know what this is, right? But we know this, and we are looking for this. So we can say that this is 10 raised to power minus 14 divided by 0.02, which is 10 raised to power minus 14 is equals to 2 times 10 raised to power 12 minus 2. I believe you understand what I'm doing mathematically, right? So this means that I have my H plus to be equals to, all right, my H plus to be equals to, let me do that on the calculator, minus 14, 0.02. Okay, so this is equals to 5 times 10 raised to power minus 13. 5 times 10 raised to power minus 13. Okay, we could even do this normally. This is then, we can bring, subtract lots of indices then. Okay, so this is 5 times 10 raised to power minus 13. 14. Alright, so sorry, I just wanted to confirm the calculation we are doing right here. And this can also be 0.5 times 10 raised to power minus 12. Either way we put it. But that means that we've gotten the one for hydrogen, we've gotten the one for hydroxide. So we can proceed to get our the one for pH. Now, either ways, you could get the POH first, but I advise that you get the one for pH. So we recall that our pH is equals to minus log of log 10, log base 10, hydrogen ion concentration, which is what we've gotten here. So that becomes minus log 10 of 0.5 times, you can use this too, but I just choose to use this, 0.5 times 10 raised to the power minus 12. Now, you see that everything that we are doing is just arranging the order of you knowing it. We use what we did here. Now we are going to use this particular aspect of what we did here. We are going to use it right here. Do you understand? So we'll be having something of this kind, where we have minus log 10 0.5 plus log 10 minus 12, right? Okay, so just like we have done that, let's move over to this side of the board so that we can. So let's just continue right here, and let me just write it again. We have log 10 0.5 plus log 10 minus 12, right? So we know that this we could have minus 12 log 10 which will give us 12, because this will be equals to 1, right? And we have log 10 0.5, right? So this we could have, let's just do it automatically. So log of 0.5 will give us, remember that we have our negative outside, so we have minus 0.3010 here becomes minus 12 because this is 1, so we have equals to minus into brackets minus 12.3010, right? And this will give us as should be this is just positive 12.3010, right? 12.3010. All right, so like this is our answer for the pH. But then remember that pH is, because I want to clarify something here. When we say pH, we are talking about the old scale. So you can hear that a pH of something, a solution has a pH of 12 or has a pH of 11. So you don't just see it as something that has to do with the acidic content alone. I just wanted to clarify that, so that because I'm sure some people say, why can the pH be this high? It means that on that range, this is the pH. But then most likely some people will say this is pOH, but this is based on our calculations, starting with hydrogen ion concentration, this is the pH. Now we'll come to the last part of the formula that says our pH plus POH is equals to 14. We've gotten our pH, so we know that our POH is equals to 14 minus 12.3010. That will give us 2.3010, just like what we got here. So this becomes our POH for this particular reaction. All right, so let's just solve one more question to clarify all doubts. Something I want to explain. I'm giving us this question to clarify what we had done earlier. So a particular question says that you are given a solution CaOH2 with the concentration 0.01 molar, and you're told to find the hydrogen ion concentration, or you're told to find the pH. Let's just use pH. You're told to find the pH, right? So now, the reason why I've been doing all of that is because you need it here. Now, remember that this is the concentration of the solution. So, for you to get the hydroxyl concentration, there's need for you to write an equation, which is CaOH2 will give you Ca2 plus OH minus, 2OH minus. This becomes 0.01 molar. This becomes 0.01 molar because it's 1:1, but this is 2. So this becomes 0.02 molar. Do you get it? This becomes 0.02 molar, and this makes you realize, okay, let's just solve for the hydrogen ion concentration here. Let's solve for the hydrogen ion concentration here because of our time. But then, after getting the hydrogen ion concentration, you could use other formulas to get your pH. So, having known that my hydroxide ion is 2 times 10 raised to power minus 2 molar, recollect that H plus and OH minus is equals to 10 raised to power minus 14. Am I right? So, our H plus is equals to 10 raised to power minus 14 over our OH minus, and we know that our OH minus is what we have gotten earlier, which is this, right? So that becomes 2 times 10 raised to power minus 2. And just like what we did earlier, I think something similar. So we have our H plus to be 5 times 10 raised to power minus 13 molar, and from this you can get your pH, which is something similar. So once again, thank you very much for joining Further Solution. Thank you for watching our tutorial videos. We hope you learn one or two things, and if you have questions, you could type it in the comment section and reach out to us if there are concepts you want us to explain better to you. Thank you. Please don't forget to like and subscribe.